Hello everyone, my name is Viraj and today we'll be looking at the 20th problem from the CP-31 sheet by TLE Eliminators under the 900 rated questions. Let's go. So moved on to my sheet over here, ticked off 900 and went to the 20th problem, AB balance. Alright, let's read this. You are given a string S of length n consisting of the letters A and or B. Now, let capital AB of S be the number of occurrences of the string AB in this S as a substring. Analogically, capital BA of S you can call is the number of occurrences of small ba in S as a substring. In one step, you can choose any index I and replace Si with either A or B. Now, what is the minimum number of steps you need to make to achieve AB of S equal to BA of S? This is what is given to us. Let us try to generalize this problem. They have given you a small reminder on what is a substring also and what do they mean by the number of occurrences of a string D in that string S. And you can definitely read this up. For example, they have given you very nicely, I want to find capital AB of this string, then this is 2. Since I can find two indices where I find for capital AB, remember we were trying to get small ab as an occurrence of a substring. So I can see there is a small ab like this, very clear, and then there is one more small ab, very, very clear. Alright, so basic problem. Let's generalize it quickly and we'll get a better grasp on what they're asking. Okay. What are we given is, we are given of course a simple string S, alright, of some n size. So I have the string S, okay, and this string S is only consistent of A's and B's. So I'll take this example only. Let's say A, B, B, A something. So let's say A, then B, B, then A, B, something like this. So only A's and B's, right? Maybe all A's, maybe all B's or a mix, but only A and B letters come in this. To be specific, small a and b come in this. Now they have defined something to be AB, capital AB's of S. Now this is just like a formal term they have given. All they mean is the occurrences of the substring AB that comes in the string S, this is this value. So in this we can very clearly see that there are two occurrences. AB comes over like this and then I think AB comes like this. So I know this is 2. Similarly, they have defined something to be BA of S, which means how many occurrences do you find of the substring B, A, as in say club together, BA letter. So you can see that BA, okay, comes one time like this over here. I think that's all it comes. So I can say, I'll mark this with a different pen. This is BA that it comes. So I'll say occurrence is only 1. Now they don't match, right, currently. What is our target? We want this to match. We want these two values to match. For that, we have been given an operation. An operation says that take up any or choose up any index and just make that character to A or B, your choice. Let's say I took this index and let's say this was B. I wanted to make it A. I will change it and this becomes A now. So wonderful. All that this operation means is you have the power to pick up any index and change the letter that is kept there. If it's B, maybe you can keep it as B or you change it to A. That's all. So using this operation and also minimize these operations, what do we have to do to actually make capital AB of S as an occurrences of small ab and occurrences of small ba equal? If we are able to minimize these number of operations, finally, I think in the question, if you check the output, we haven't been told that we have to print those steps. Rather, we have been told that you have to print the resulting string. So let's say you did some operations, for example, and let's say you change some B to A, some A's to B. Finally, whatever is the new string, I'll call that string, let's say S dash, you have to print this. All right, then automatically the platform will check it for you whether it's one of the right answers if possible or not. If it is, you definitely get an accepted. If it's not, or if it's not in the most best case operations as in minimized operations, then in that case also you get a WA or a wrong answer. All right, so this is the problem. Let us understand this with a quick test case so that it becomes clear. Let's all talk about this. All right, very, very simple case, or even I think the last case is much better. A, B, B, A, A, B. All right, so I'll take this. You have the string that looks like A, B, B, A, A, B. Now on a quick verse, what's the number of small ABs as a string that comes, right? So I have this AB and then I have this AB. So this is of course 2. And BA. What does this come? Of course, I have this BA only, so I can name this as very well 1. So I know they don't match, right? So I have to do some changes that either they match, right? They of course have to match in this case, and I want to minimize that. So what's the best thing? Like the answer according to them is A, B, B, A, A. That means basically I can work on the last index and I can change this from B to A. If I do that, my string now transforms itself to A, B, B, A, A, A. Now, if you do a quick overview again and count the AB occurrences and B occurrences, basically now AB comes how many times? So this is AB, that's all, I think 1 time. And what is the BA count, right? B as a substring, 1. So don't you think 1 and 1 match? Of course they match. So that means we did only one operation, right? Only one operation, and you were successful to make this final change that ABs became equal to BS, or this whatever definition they gave formally, capital ABs of S became equal to capital BAs of S. All right. And this was ideally in the best case, only one operation that we took. Hence, this is definitely a good answer. Alright, so I hope the whole idea is clear. Minimizing is the main idea over here, but added to that part, it's not a very classical way of normally when problems ask you what's those number of operations are. They are right now preferring you actually print the string after you must have performed those operations. That is, in this case, we did that one operation. We said string becomes A, B, B, A, A. I printed that, and this would be taken as an answer. Alright, so the problem I think is pretty much clear. Now, let us discuss the expected time complexity in this problem. All right, what are we looking for as comes to the time complexity for this solution? So we are given 2 seconds for every test. All right, and we know generally that 1 second basically allows me 10 power 8 elementary operations. Now, if this test is allowing you 2 seconds, which means that one test basically allows you 2 into 10 raised to 8 operations. Pretty simple. Now, inside every test, there is a test case, that is this value t, that is in 1000 order. So we need to also figure out the number of operations you might perform on an average for every test case. That would now turn out to be, you write 2 into 10 raised to 8 operations upon 10 raised to 3, that is 2 into 10 raised to 5 operations. So this is the average number of elementary operations you are allowed to perform for every test case. Now, inside every test case, there is this S string that is given, and then you have the length of the string, that is this mod S, you can say, of 100 order, maximum 100 order. So we can consider that to be this n value, standard thing, n to be the size of the string S. So now if we consider n in a order maximum of 100 for every test case, can we create a solution that looks like n square? Definitely, we can create a solution that looks like n square, because n square would take us to 10 power 4 order, which is definitely less than 2 into 10 raised to 5. Even if we go little above this, maybe like say something like n square log and stuff like this, it's going to work. Not that we might create solution like this, but this is somewhere we can good enough go to. But we will stop somewhere when we go in a cubic form, because cubic means we are going in some sort of a 10 power 6 order, which is definitely above this. So solutions like this don't work. N square log n square, and then if we come down, preferably we create something like O of n, so on till you create a constant solution. If you are able to do, then all of this is good to go. So we know that right now in our head we are looking for solutions in this limitations only, and solutions after that are kind of a disgrace for us. We cannot do that. So this is our expected time complexity discussion. Now I would prefer that whatever logic I create runs either of in this order only, right? Preferably something very optimized, since we want a good solution to the problem. But nevertheless, we have a general idea of what solutions are we looking for. All right, great. So this is our expected time complexity discussion. Helps me to remove all the redundant ideas. I won't think in cubic solutions anymore. All right, so now let us come back to the problem and look at the solution in this problem. So this problem has a very standard argument, which comes from a very simple observation. Okay, first of all, we need to ask ourselves that although it has been told to you that you can change the string, it might happen that you don't need to change the string at the very instance, right? That's the first thought it can come to the mind. Very intuitive, right? What if I don't have to change the string? When would I suggest that particular thing to happen? That would of course be in a case when I already know that small ab's and small BAs match, as in the occurrences match, right? It can happen. For example, I'll give you, let's say the string initially looked like A, B, B, A. Now in this case, you have one AB and one BA. Now, don't they match? As in the occurrences match. If the occurrences match, do you have to do something? No, you don't need to do something. You can say, basically, I would want to print the string as it is. I don't need to do any change, hence minimizing my operations also, and definitely printing the right answer. So I know that if the ABs and BAs match, I don't want to change anything, print that string directly. Now, this would be my next question. Is there some generality in the strings which occur for which AB and BAs as occurrences actually remain same? Is there? If there is, maybe we can try to build on that. And this is where our whole intuition, our whole idea of the problem will lie. What we can argue is, let's start asking, what if ABs was equal to BAs and this was equal to 0? What now? Maybe the string can, like, I'll take an example. Maybe the string definitely in this case looks like all A's, right? Or maybe the string looks like all B's. In this case, we know it's 0. Very simple. If you have no occurrence of AB or BA and both are 0, that means either it's all A's. If it's all A's, you don't find AB, you don't find BA. If it's all B's, you don't find BA. So same thing. So this is one of the type, right? Let's take more types. Let's say AB and BAs were equal. So we are taking, of course, the equal cases and they were equal to 1. Now what? Let's take a general example. How would the string look like, to be specific? To my mind, if you do a 2-minute thinking over this, the string will either look something like this, that it starts with A, then let's say there is a B, and then there is an A at the end, right? Something like this. Or maybe it starts with B, then there are some A's, and then it ends with a B. I think these are the only two cases, meaning it starts with A, some B's, then ends with A. It starts with B, some A's, and then it ends with B. Now, in this case, of course, very clearly observable, AB, BA. 1 month time coming, right? BA, AB, 1 month time coming. So this is a good example. If you generalize this, we agree that, okay, some A's, B's, some A's, or some B's, some A's, and some B's. Basically, I understand that if I try to continue this pattern, what will I observe? Try to understand this with a very simple sort of a visual thinking in your head. Basically, when you go from one letter to the other letter of nature, as in if I have some A's, for example, let's say I start off with some A's. Yeah, you're going some A's. As soon as you switch and you turn on to B's, you create an AB over here. That's very obvious. Now, if I'm arguing that you have to keep the AB and BA counts equal, that would mean that after some B's have been covered, you will again have to switch to A. So up till here, you inserted, you basically, if I had the count of AB as AB and BA initially as 0, as soon as you did your first switch, you incremented this count, so this became 1. Now, because you want BA also to increment by 1, since BA and AB's occurrences have to match, in this case what we're talking about, then you would want to switch back to A's. This again switch would have to be made. Now, let's say again you continue on your path and have some A's and you make a switch. Let's say there's one more B. As soon as you make a switch, since you increment your count one more, you will have to continue with some B's and again turn back to A and make this switch, which would make this increment go back to 2. What this means is, if you start off with some particular letter, in this case, the letter A, let's say, you make one switch, you will have to create another reverse switch or another change in the letters once you actually tend towards the end to keep both of the counters same. As in, one goes up, other follows. One goes up, other follows. Which is why I'm going to keep a very simple statement on my whole idea right now. That is, if I want ABs and BAs to match, as in occurrences to be equal, then for short, by this simple visual proof, I would argue that the first letter of my string and the last letter of my string have to be equal. This is my argument. Let's visualize this once more. You're starting off with some letter, let's say A. You switch to B's. You will have to again switch back to A's and then end yourself. Both the counts are equal. There would be 1, 1. Let's say you did one more switch. You will have to again back switch to A. That would make the counts 2's. If you wanted 3 counts, you again switch to B, again come back to A, and so forth. So remember, you started with A, you ended with A. Be it the count 1, 1, be it the count 2, 2, 3, 3, 4, 4. If the counts are same, if you started with A, you have to end with A. And vice versa. I can just replicate this logic on B's. If you would have started with B's, you would have end to B, which means this is a very simple intuitive argument that if S of 0 is equal to S of n minus 1, that is the first and the last letter match, basically operations are 0. which means print S directly, and this is good to go. This is a very simple idea. All right. And this covers almost all our cases where we feel AB and BA count match. All right. Which means if we term this as our first case, we are obviously left with just a different case, that is second case. What if S of 0 was not equal to S of n minus 1? As in, what if the last and the first letter were not same? Now, because I proved this by simple visual ideology over here, that if first and last letters match, then you know B and BA's match. It's very obvious if the first and last letters don't match, then AB's and BA's are not equal. Now, if that is the case, I will have to make them equal. Now, understand this very simple over here. When we did this whole like simulation of switching from A to B, B to A back, what did you observe? Once the count of, let's say, AB went up, then BA followed. Then AB went up, then BA followed. What if I had not ended on the same letter? Let's say over here you had, so up till this place we had already simulated our case. So we had said that, okay, 2 and 2 are AB and BA counts. That's great enough, good to go. What if now we switch back and we end on B? All right, let's say I make some more A's and then I end on a B. Now, you know, of course, as soon as you did that, AB count goes to 3. And you can see the first and last letter don't match. Don't you think that basically in our simulation, it's pretty obvious that at most there is a difference of 1. AB and B in this case can be seen, this is 3, this is 2, which means there's an at most difference of 1, which clearly comes from the fact that when we simulate in our head, because you did one extra switch for which you did not cover up back, you basically made an at most difference of 1 in both cases. So either you would have switched again with a letter of A and you would have made everything equal or balanced. Now it's not there. They are unbalanced now, so which means that the last letters did not match. And this is basically our case number 2. Now, if I have to handle this, what should I do? Very obvious. Either I change, because the first and last letters don't match right now, I can just make them match. If I make both the letters match, then I would be indirectly making sure that the whole pattern again falls in the paradigm of case number 1. And if it falls in the case number 1 paradigm, then I know this S string is good to go, since we knew that case number 1 paradigm string dictates it has equal ABs and BS. So that means I need to perform some operation, that's true, but I need to actually perform only one operation. It's my choice. Maybe if let's say the first string is A and the last letter is B right now, so A and B, maybe I change the last letter to A. Just one operation, and I have made the first A, last A. Falls in the paradigm of the strings which satisfy my condition. An operation that I did was also minimized because that's the least operation I could have done. That's actually 1. You cannot go, like, you don't want anything more than 1, and 1 is a good number. 1 is just a single operation that you performed, and yes, you got a string that's good to go. It falls in the first paradigm. So this means that we can, up to our choice in second case paradigm, what do is we can either change S of 0, right? Change either S of 0. As in, change means if S of 0 is A, then you change it to B. If it's B, then you change it to A. Or we can also change S of n minus 1. Same thing, right? We can either do a change on this. Same thing, as in either if S of n minus 1 is A, we change it to B. If it's B, then we change to A. And then we keep the rest of the string as same, because if S of 0 changes its nature, it will automatically match S of n minus 1. If S of n minus 1 undergoes the change, then it will automatically match S of 0. So somewhat or the other, you can say that the last and the first letters will automatically match, which would again make me fall in the first case paradigm. How much operations would I do to do that? Of course, only 1. So yeah, good to go. So that means overall in this case, what we would be printing is just, now it's my preference, I'll prefer S of 0. So what I'll do is I'll change S of 0. I'll concat it with all the leftover substring that starts from after 0th index. And this, like you can say first index onwards. Okay, onwards, something like this. And this overall as a string can be taken out and said, this is my answer. This would have basically taken one operation, and this definitely has been balanced now. This was our main question. All right. So I hope the whole idea is now clear. All right. What we'll do is we'll look at the cases once more so that we get a good picture. Just a rough brief over the cases. If you look over here also, let's say in this case, we can clearly observe that since the last and the first letter did not match, what we did was we changed the last letter to A. Now, assuming I took this case only, okay, we took A, B, B, A, B, and let's say I would have changed the first letter to B. That is, if it's A, I change it to B, vice versa. So this becomes B, B, A, B. Now check back again, 1 and 1. Isn't this whole satisfied? Yes, it satisfies, because why? The idea is the first and the last letter now are matching. So this would also have been an answer, or you could have changed this to A. That would also have been the answer, and they actually have used the second thing to be have printed over there. I think I took one more A's there in the middle, but then you get the idea. All right. And same case over here. If you look at case number 2, case number 2 was not at all hampered because the last and the first letter matched. That was A and A. It did not need any change. The third string, however, did need some change because A and B don't match. So they prefer to change the first letter in this case just to confuse you, but the idea remains same. And now we can see it basically creates a string that has 0 ABs and Bs. All right. Great. So I think we have understood the question well. Let us look at the code part now and understand the whole thing. Very, very simple code, right? As we pictured, you have the string S, you take the size of that just for calling the last index. You could have either not taken that, it's totally up to you. Now, if the first and last letters don't match, then I need to change something. What do I need to change? I need to change basically for my preference, the first letter. If the first letter is A, I change it to B. If it's B, I change it to A, vice versa thing. And then I can directly print the string S. So if the letters don't match, then this happens and then S gets printed. If they already match, then you do nothing, which basically means 0 operations and you directly print S. So I just modified S itself and that creates my answer. Very simple and clean code. Now, what's the time complexity? You will have some time complexity to input the string. We can take that as an n order. But this check over here is basically pretty much constant. So I can say time complexity majorly comes from just the input parts, which is O of n. So that can be O of 100. Now, this is definitely good to go. We wanted something that is like n square log n something order. We could also go on. O of n is definitely working for us in this case. And what about space? Space is again O of n. That is dependent on the string size. That is O of 100 again. So well-balanced solution. We are within our boundaries and this definitely gets me a accepted on the platform. All right, it's fun problem, very observation-based problem. All right, it starts off with a very intuition on the part of how and when is ABs and BAs equal. If you begin from that area, then the problem simplifies itself to a very clean solution. All right, so I hope you like the video. Thank you for watching.